Before we start, let's take a look at the electrodes I'm using. These are ordinary metal washers, but they work surprisingly well for this project. Washers are inexpensive, easy to find, and can be stacked together to create a much larger surface area. A larger electrode surface allows more electric current to pass through the electrolyte, which helps improve the efficiency of the electrolysis process. This makes washers a simple and practical choice for building a DIY hydrogen generator. For the main chamber, I'm using a glass container instead of a plastic one. Glass is generally more resistant to many chemicals and is less likely to deform from heat generated during operation. Now I'm adding potassium hydroxide, also known as KOH, to the water. You might wonder why this step is necessary. The reason is that pure water is actually a very poor conductor of electricity. By dissolving potassium hydroxide into the water, the electrical conductivity of the solution increases dramatically. This allows the current to flow much more efficiently between the electrodes, resulting in faster and more effective electrolysis. It's important to note that potassium hydroxide acts as the electrolyte and is not consumed during the reaction. Now it's time to connect the 12-volt DC power supply to the electrodes. As soon as the current begins flowing through the solution, electrolysis starts. During this process, water molecules are split into hydrogen and oxygen gases. The hydrogen gas travels through the outlet tube and forms bubbles as it passes into the water. These bubbles are clear evidence that hydrogen gas is being generated continuously. In this step, we're going to test the hydrogen bubbles. Hydrogen is one of the lightest elements in the universe, and it's also highly flammable. When the bubbles reach the surface of the water and come into contact with a flame, they ignite almost instantly, producing the characteristic popping sound. This simple demonstration clearly shows one of hydrogen's most well-known properties, its extremely high flammability. For the final demonstration, you'll see what can happen if a hydrogen-air mixture is ignited inside a closed container. The flame can rapidly ignite the gas, causing a sudden increase in pressure that may rupture the container. This demonstration is intended only to illustrate why hydrogen must always be handled with extreme care. Always use appropriate protective equipment, work in a well-ventilated area, and follow proper safety precautions whenever working with hydrogen gas. Look at how this happens.